if you're ready, we can start talking about the anatomy of Java vulnerabilities. Introduce myself in a second, but this talk is going to be helping you understand about Java vulnerabilities, what they are, why they're important, and this is going to be a slightly different talk because I'm not going to tell you all the truth. I may lie to you occasionally. I may hide things because I need to not share everything with you. So if you're coming here for smoking guns, here is a big picture of a latest vulnerability, you're not going to see it. But I'm going to lead you to think about what they are. So this is a big picture of me. I was very tempted to put my face in the whole thing because having a 50-foot face would be just fantastic. So I work for IBM. I've worked for IBM since, well, a long time. This is my 25th year at IBM. And I joined 92, did a few bits and pieces, and then I joined the Java team when Java sort of started. And I've done a lot of Java stuff. There's lots of activities around Java, so not just JVM development, there's all sorts of other activities. So I've done lots of open source stuff, and I've also done a few years as a DevOps lead because I needed to learn stuff. And it is from the DevOps side that this talk originates, because as a Java programmer, like probably the majority of you, you don't really get what's going on in the wider world. So I learned that from being a DevOps guy, and part of the talk here is bringing back what I learned. So this talk is going to be scary, and if you're not scared, then either I'm not doing it right, or you're tougher, right? I'm going to show you some slides which have black background, and that'll be the scary stuff, and yellow slides, hopefully it's the technical pieces, and code will be in blue, right? So let's start with, what is a vulnerability? So a simple definition is a vulnerability is a bug which somebody exploits for gain by an attacker. Okay. So that then gets you into what does exploits mean? And exploits come in all sorts of phases and shapes, which is why we have so much fun with this stuff. So they can attack your availability. They can find a vulnerability in your system, and they can bring your system down. They can cause it to crash. That's one you'd notice. And there are quite a few examples out there where people are able to do denial of service attacks, or in things even more closely to home where they can actually get code running on your system that SIG save Vs and brings the VM down. Lots of those. The classic is just making use of your CPU, hitting you with all sorts of traffic, those sorts of denial of services, but more flavors on that. They can hit your integrity. So they can modify your application data. They can get into your system and they can change things and you don't know about it. And the perennial, they can run code. So they can insert code and they can run code, right? And then there's the really horrible thing where they can find ways to get privileged elevation. That's where you're running something and through a vulnerability, you're now able to run as a root or something. And of course, those sorts of things open you up to losing all your sensitive data. So you could say, yeah, this happens. This is just the world. The world's like this. As a Java programmer, why should you care? Yeah. So now let's do some of the scary bits. So you've heard, we all hear about vulnerabilities and we all hear about patching them. And then you hear about denial of service attacks, but probably nobody puts it in context for you. So let's talk about cybercrime for a little tiny bit. Many people have the perception that cyber criminals are these lone guys sitting in their bedroom, 15 years old, hacking. Right? It's not like that at all. Here's the really scary bit. Cybercrime is organized. It is very organized. And it's very, very profitable. So you can see some numbers. In 2016, cybercrime was estimated to be worth $445 billion a year. That's 1% of the world's GNP. The drug trade from 2013, okay, was slightly less. So given the dates, maybe you could say it's about the same. But think about that. You think about all the consequences we suffer from having this illicit drug trade, and now the cybercrime side is the same and growing. Right? The expectation is by 2019, $2,100 billion. There is no sign of it stopping. It is the most profitable crime going, because right now we're letting that be the case. It's growing the fastest. It's almost impossible to prosecute these guys. Right? There's no risk. These guys, if they're organized, they just wipe the floor with us. Right? So just bear that in mind as we go through this. So let's get off the scary stuff. Let's talk about vulnerabilities. Who'd like to see an example of a vulnerability? Yes, right. So it may not be what you think. So let's start with some code. So I have a path. So on this machine I have here, user spool foo bar. So I have a directory and it's got a space in the name. And I want to write some Java code and I want to reference it. So I decide I'm going to reference it as a URL. And so I encode it and I get my %20 instead of the space. Okay. And then I write some code to play with it. So there's the URL, and I create a Java file from it. I get the path, and then I run 2 bits of code. So I say, print out the absolute path of that file, and I say, does that file exist? Okay, nothing special. So here's the answer. The path is foo %20 bar, so it doesn't exist. So the test fails. So actually what I do is I just forgot to decode it. I didn't add in the bits that are necessary. Right? So if I add those in, so now I add in a URI. So I take the URL, convert it to URI, so it'll do the decoding for me, and it'll turn the %20 into a space. Right? That's all I've got to do. So when I run that, I now get the path that I was expecting, and I get exists equals true, because it's true, it does exist. Okay? Now think about this. If somebody had managed to get onto my system and had created the path that I originally looked for, foo %20 bar, I'd have found it, right? And so the answer would have been true rather than false. Okay, not a big deal. You know, people don't get into your system, so what? It's a little thing. Here's how it works. On Windows, anybody can create file directories in the root. It's just like the way it is. And somebody can create anything, right, with those names in. Okay, maybe that's not a big deal. Maybe you don't see the join. So what happens, let's go Java example. So we all have the extensions mechanism. What happens if instead of foobar, I have, by accident, a file path that's got my %20 in, C:\program/2020 files, common thing, right? Okay. So it could be simple example of it's in my extensions directory because I have some relationship between things I've got installed, and so it's just there. I don't have the product installed, so nothing bad happens. It just gets skipped as the system is expanding. But because anybody can create the top one, I could create C:\program %20, and suddenly, if I have a library on there, and I have the right name and all that sort of stuff, suddenly I can load your code. I can load my code, right? And that is a vulnerability. That's where you have two combinations. You have a combination of a mistake and a combination of somebody who knows some other part of the system, and they get joined together, right? Suppose the JVM had this bug in it. Suppose that you found that this thing existed on the JVM, and somebody got into a system and created that file, that directory, and allowed DLLs to happen, right? So not quite how it is, but very close. That's a bug, very similar to a bug, vulnerability that was fixed in the JVM. I'm not going to tell you when. I'm not going to tell you any more details, and we'll talk about why in a minute, but that's a vulnerability, right? There is no smoking gun in vulnerabilities. There are no big things. It's very, very rare for you to look at a piece of code and go, that's a big vulnerability. It doesn't work that way. Vulnerabilities are things that we do for our purposes. Sometimes they're bugs, sometimes they're others, and they get exploited because people think of new ways to exploit them, and they join them together. So some of the exploits that are knocking around today are very complicated. Very bright people have worked out how to connect vulnerabilities together to get the effect they're looking for, right? But that's the level set. We've got some really bad guys who are making loads of money, and they're looking at our code and they're finding simple ways to join them together, our weaknesses, to create these vulnerabilities. So let's just talk about who the bad guys are, because you need to get this as well. It's not these guys. These are just random criminals from the 1920s. I doubt that they were doing programming then, but you never know. The important bit to take away is that these guys are mirrors of us. Now, I'm not going to impugn anybody in this room, but it's very likely that if you go to a technical conference, there will be people there learning things for not necessarily the same reasons that you might be learning. They're very focused. They put lots of money at it. They get very well rewarded. They're very goal-focused. You know, they use Agile. They use Scrum. They do these things to get the best out of it, right? And do you know who they go for? Well, there's the usual sort of stuff you've probably heard. They go after the middle-level execs. They go after people who've just joined companies. They're looking for weak people, people who are exploitable, and they go after us. We are one of the best targets for them. And that's for a whole bunch of reasons that you can see there. Because we are on the inside, right? We write the code. We're the ones that go, I must have root access to all my machines because it's so easy for me to debug if I have that capability. We trust stuff. We use other people's code without inspection. Now, I can guarantee that lots of you have company policies that say when you use some third-party code, you will be checking licensing terms. But I bet you none of you are thinking about, how do I assess whether that code is genuine? Where do I get it from? Right? If I go to Docker Hub and get a Docker image, and I see the license, is that all you do? Do you go assess whether the person who put it up there has some reputation? How would you know? And we don't do that. And we install things that install things that install things, and we don't think about the consequences. So we're very ignorant of this. Right, now, partly, it's not our fault, partly because of the way the world works, we're all very quiet about sharing with developers what the issues are. Right? But I'm here because I know we need to talk about it. And again, I'm still under the same sort of, I can't tell you all the details, because of the fact that the problem that we have is the bad guys know about us, they can read all our stuff, they use our code, we don't find them. So we can't talk in the open. Right? So maybe that's not you, right? Maybe you think that you're not one of those people. Maybe you think you take this stuff seriously. So how about this? How many people have ever Googled for any of these sorts of things? How do I trust any SSL certificate? How do I get a very trusting trust manager? How do I turn on certificate validation? Yeah, okay. How many people have done this? How many people have written the very, very, very trusting trust manager? The important line being the is client trusted, return true, and is server trusted, return true. And do you know why we do that? Because it's easier than fixing the root problem. We're very good at solving these issues and not coming back. Right? And sometimes we build it in. Sometimes we make it a feature. So that means that it's not just a vulnerabilities bug, it's also vulnerabilities of features, right? Things that you built in that you thought were good can be exploited, right? And so that it's just life, right? There's nothing we can do about it in terms of other than being more cognizant about our actions. But the net is, it's the small weaknesses that get joined together, right? And we have a whole world out there that is trying to find these things. You know what the situation is in terms of cybersecurity. You know, it's getting worse every day. And so everybody's trying to fix it. We have a role to play. So let's quickly talk about what other people do, and then we'll talk about some more examples. So there is a process. In the Java space and wider, there's common vulnerabilities and exposures, CVEs. That's the acronym you're looking for. There's more than one website. That's just one. Go have a look. The community is getting together. It's really important, and to be honest, this has been going on for years. It's really important that when we talk about a vulnerability, that we don't talk about the details, we all talk about the same vulnerability. So we all know that it's been fixed. So we have CVEs, and we can track those through, right? And if you go to that website, so these lists are from a couple of years ago. I did a refresh last week, and you can see them. So you can go to CVE, you can go to the MIT.org thing and put in some keywords. Do not be surprised to find vulnerabilities. So one of those is just Java, and one of those is Java and serialization, right? So if I get let's take the current list. So this is Java serialization. These are this is of last week. I just did it. These are top 3. This is not a priority order, they're just top 3 of the list. And you can see those words, okay? And you can see a common pattern in the word, because that's all you get, an unspecified vulnerability that allows remote attackers to affect confidentiality, integrity, and availability, right? Now, here's our problem. We need to educate ourselves on the circumstances of the code that we wrote that allowed that to happen without sharing the specifics too much, right? If you share specifics about a vulnerability, right, nowadays there will be an exploit almost instantly, as long as it takes one guy to code something. So we don't want to talk about it, right? Right. So basically the way to think of this is, if you were to share the consequences, the details of a fix, it would be the same as you taking your credit card number and your credit PIN and just sticking it on Twitter, right? That's how important it is not to share the details specifically. We're trying to ensure that these guys have to work hard, right? So we don't talk about the specifics, but we talk about the impact. So you can go visit websites, and you can go see the CVE website, and you'll start to see that we have common ways of assessing them. We're going to talk to you about how bad they are, and I won't go into the details, but you can guess the sorts of things. There's a whole bunch of people out there. IBM has this X-Force research group, which are pretty renowned for tracking all these things and getting the information out. And so we look at how we score them and giving you the information about whether it's got an impact. And then you have to figure out whether that impact is high in your circumstances, okay? And the other thing to bear in mind is that these things evolve over time. So you might come here one day and it's got a low CVE score, and you might come in a week's time and find that we've realized that in fact there are other issues with it. So you have to keep tracking on it. And here's an example. So again, you can see the words, right? We assess it from all sorts of ways. The important bit to remember is that these are done by people who assume that you are behaving reasonably correctly in your security posture, and that if you just ignore all that, then all bets are off, okay? Just worth pointing out. So, how are they communicated? So, I'm going to talk about this. I'm going to talk about how they're found, and then we'll do some examples. We are always publishing information about vulnerabilities. Oracle do it, IBM do it. CPU Advisor it's a constant stream. There are lots of places that you can go to find the information. You can go from IBM, you can go find it Oracle, right? Oracle put out their critical patch updates to CPUs, and they have a process, and we repeat that process. We do it on a regular basis. Why do we do it on a regular basis? So that you can get your schedule sorted out. So there's no emergency, oh my God, Oracle have released a fix pack, we need to install it. There's a whole stream of stuff coming out, so you need to fix them, right? Now, I have this conversation with other people and they go, well, I can't do that because every time I do an update, I have to test it. So, it's your call. What do you do to test it? Do you put effort into testing it? Or do you ignore it and have systems that are back level, have more vulnerabilities in them, which make you an easier target for the guys who are out there trying to get your money? Okay. Anyway, so we're trying very hard to give the right information on a regular basis so that everybody can keep up, because it's a constant stream. So the IBM have this PCERT team across all of the IBM products, and it's the same sort of thing, right? And we try and keep everything in sync, right? Our PCERT process, we try and keep up with Oracle. Obviously, everybody talks. The security guys from all the companies are working together on this. There's no race here. There is no commercial gain. It is important that everybody gets stuff out as quickly as possible. So you might ask, where are they coming from then? If this is steady stream of vulnerabilities, where's it coming from? Okay. So, development teams that are creating products and JVMs and things of certain sizes will have teams that are looking for this. It may just be a testing activity. They may actually have specific individuals who are tasked to look for this, but everybody's looking. Nobody will ever publish the exploits, right? That's the best bit. In fact, sometimes it's really good just to put your test team on this, because test teams have views of how to break products, and that can help them get into discovering the vulnerabilities. Right? There are third-party researchers, and you will have heard about them. Many people out there are trying to help it get better, and they're trying to find the vulnerabilities. Now, the problem sometimes is that they get very clever and find vulnerabilities that maybe nobody else would have found, but once it's found, once it's out there, you have to deal with it. And then we have the bad guys who are doing the same thing. They sell their discoveries, and they obviously, as we're beginning to see, sometimes they use the vulnerability not just to get into your system, but possibly to exploit some money from you, and we'll talk about that in a minute. Lots of people trying to find this stuff. Maybe you would find one, right? So maybe you would discover a vulnerability. Maybe you're looking at a piece of code and go, oh, I can see a circumstance where it's just not tight enough. You know, I'm doing this, and maybe I'm being too generic. Maybe I'm too open. And you suddenly go, maybe we should do something about this. Don't publish it. If you find this, if it's in your code, fine, just go fix it, right? And figure out how you tell your customers that you've discovered a vulnerability. If it's in the JVM, then depending who owns it, then just report it. The slides, when they go on SlideShare, these are all links to the various sites, so you can go do that. Please don't publish anything about it, right? Nobody will love you for it, and possibly some people will come and visit you, right? Don't worry about whether you think it's big or small. We're going to do more examples. I think we begin to see that vulnerabilities are little weaknesses that build up. So if you think there's an opportunity for it to be exploited, then just talk about it. Just email these guys. Right. And then, of course, we're going to fix it. Trouble is, we're not going to fix everything all the time, because it takes time and effort. And we want to ensure we make it correct and that we don't break things. It's the usual sort of thing. So, in general, all the development teams are putting as much effort as they can afford into getting this to happen. Obviously, it's based on priority, and when urgent things come through, we'll fix it, which is why you sometimes get emergency releases. Okay. So I've talked about the bad guys. I've talked a little bit about how simple some of this stuff is, and you can see that we're all, as an industry, we're trying to work together. So you might ask yourself, does this really matter for Java? Right? How bad is Java broken? Right? So Java reputation is not good. but actually the majority of the reputation that Java has in the real world is to do with the plugin, and we all know that. And we know that that in general is going away. A lot of this stems back from when the internet started, and that the idea of security was sort of just really wasn't around. Right? And we knew about it, but it was like, yeah, we'll get around to it type thing. And it got worse for Java. 2013 was pretty bad, but right now, you're not too bad. We've got this 10 CVs of CPU. That's not bad, right? And if you look at how it distributes, you can see, if you can read that, untrusted code is the big one. There's applets and untrusted code. So many CVEs that we fix are to do with plugin or applet space. Untrusted code, cryptographic issues. That's weaknesses in cryptographics and things like that, and then other. So it's not bad. This is percentage distribution, by the way. So 70% of the problems that are reported are mostly in the plugin space. Okay, so that's good. So that means when you're assessing these vulnerabilities, you can start to make some assertions to yourself. Okay, I've seen a high CVE. It's got a high score, but it's to do with the Java plugin. Okay, don't care. I've seen another one. It's to do with JAX-P. That's okay. I don't parse XML data. No problem at all. Okay? And you can look at these things and you can make some assessments. The problem is that what I find is I talk to people and you might go, I know what my code does, so I think I know that I don't do JAX-P parsing. But you may not know what your dependencies do. How do you know? Do you go checking? Do you go reading? If they have a dependency of something that's inside the VM in the class libraries, you might not notice, right? Right. And the other thing is, generally we don't know all the dependencies. With things like Maven and stuff like nowadays, you just get long lists of stuff, right? So a worry here is that we're not very cognizant of what we're using, and we're not very cognizant of the possibilities for vulnerabilities and the stuff that we're using. So let's talk a bit more about the vulnerabilities themselves. How do they get in? What are people looking to do? What are the attack vectors, as they call them? Right. So we have things like, we talked about untrusted code. So there are things where, vulnerabilities where we can get past the security manager. That's a pretty good one, people looking for that. I don't know if you get this, but the bad guys are looking at GitHub and they're downloading the Java classes from Maven and they're reverse engineering. They are actively looking for these sorts of places. So they're looking for security manager vulnerabilities. They're looking for places where you haven't quite got it caught, right? And if they can find the flaw on anything on your class path, then maybe they can exploit it. But you don't even have to install code, right? And then other things like, as they say, partial bypass and full bypass. You get the idea. It's about looking for ways. Untrusted data, untrusted code is, can I run your code in a different way than you're expecting to exploit stuff? I'm not giving you code. Then you get down to arbitrary code execution, where in some cases the code has been installed, and I'll talk about one of those in a minute. Right? But it's about that. In that case, it's like trying to find some way to get code on your system or run code that you already have that's reachable. Right? And there are some good examples of that. Then there's the plugin and web start. The good news is that that is finally going away. This is what they call about client side. People get confused, and sometimes you hear about vulnerabilities on the client side, and they don't mean client, they mean server. So client is browser side, right? And that, of course, has a history of there being so many of those. And there are just so many places where you can get in, which is why, at the end of the day, we're just having to remove it. Now, there's another side, which is the untrusted data. Now, this is interesting. This is where you receive data, and the data I send you can be formed in such a way that I can make your code do something else. So the really simple things like denial of service. then I'll talk about one of these in a minute, but basically, can I send you some data that means the JIT spins, or you spend a lot of time in a CPU in a thread loop, right? Can I form some data that you weren't expecting to receive, that you weren't checking for, and can I make bad things happen? So a lot of that comes because we actually have, our systems are very much designed at a higher level to be in that sort of space. And especially in the software as a service business, where we're talking about receiving data from third parties, from our clients, they can send you data, and they can make your system go down or do these bad things. Right. So, okay, I'm telling you the description. I haven't got any vulnerabilities in this space, but we'll talk about that. I have one. So let me talk about this. This is recent. A JPEG vulnerability. It's the one that makes you open your eyes to what we're talking about. So this is an example where there's a vulnerability in the JPEG C code, so that when a particularly crafted image is loaded, not a kitten, okay, what you get on the system in memory is possibly the kitten, but also some other code. And the code is crafted because it's a buffer overflow. Basically, more code gets loaded into memory than is expected, and it overwrites things. Now, it turns out that they've managed to find a vulnerability that lets them craft remote execution, so they can get into your system. So if you had a web page that allowed you to upload an image, and you had this vulnerability, I could now install code, or I could now get your code to run and do something, to run something that you weren't expecting. Right. The important bit is you don't think about images as being data, but it's all about data coming in. Any data that you receive, if you do not validate it, and even these sorts of things, you run the risk of bad things happening. Now, it may be that 9 times out of 10 or 99 times out of 100, this particular vulnerability ends up just crashing your system because it overwrites the memory in such a way that, I know, it's 6 XVs. But then it'll be right once. So cryptographic issues, another sort of attack. That's mostly flaws in implementations. There are and simple things like Heartbleed, for instance, which is not really a cryptographic issue, but those sorts of, there is a bug, right? And implementation flaws where you think your cryptography is secure, but somebody understands that they can break it under certain circumstances, right? And again, well, that's just life. I'm not saying this is good or bad, this is just life. The important bit is that you understand that these are the styles of way people are getting in. People are looking for these vulnerabilities, right? You have to accept that there's a whole industry, a dark industry, that is exploring these things to get into your system. The takeaway is, in all of these things, is that you have to be more aware of what's going on. Right, last one. Attack vectors, local. Now, this is, you have somebody who has access to your system and they do bad things to you. So that's on the basis of I log in and I sudo to root and I do things. There are instances where people do that. What can you do? Right? Now, the weird thing is so many of these have a low CVS score because the assumption is that you haven't given that level of access. Okay? However, you may think you haven't, but actually you may have. Anybody seen this? Right. There's this thing, Wannacry. It's still running. Friday, it's really good. I was doing this same talk very much at Devox UK, and I was talking afterwards about there's going to be a big attack at some point, and then the day after, boom. So it's not my fault, right? But it's massive. The reason it's so massive, apart from the fact that it's because of the vulnerability that they're exploiting, which we can talk about separately, is also because of where they are with Bitcoin. Because Bitcoin is a fantastic way of receiving money without being traced, right? So you see what, they've taken down hundreds of thousands of machines, and currently they're making about $3 for every one that they infect, okay? The mechanisms underneath Wannacry, which are about getting remote execution. So the ransomware is a payload on top of another system to get remote execution. It's a vulnerability in the OS, which should have been fixed, right? Your systems may have the same one. If your system is connected to the outside world in any way, you may have the same sorts of vulnerabilities, okay? So you cannot assume that people don't have local access to your machine. They may not be able to log on, but they may be able to get payloads to your system. Okay. So let's talk about some more vulnerability examples. So serialization. I tried to put together a picture for this one, and I sort of lost the plot. How many people here use serialization? Okay. Okay, let's ask differently. How many people here write Java? Okay, right. Anybody who said they wrote Java but don't use serialization, that was probably wrong. Because even if you don't use serialization and you provide some code, somebody else may serialize your code. Serialization is a really great way of getting these vulnerabilities in, because serialization has things like read object. So you think about serialization is to take a set of data in a graph of classes and objects and convert them into some text files or into text data, binary data. And then you send somewhere else and it gets deserialized and wonderful. I can send you a payload that I've crafted, and if your code has, if your class has a object slot in it and you don't do any checking, I might be able to put into that object slot an instance of an object you weren't expecting. If I know that if you've got the class on your class path, I may be able to construct a sequence of Java serialization bytes that when you deserialize can drive you down a path you weren't expecting. Right? And there are some nasty examples out there. The Apache Commons one is the one that most people point to nowadays. And that's basically a very complicated, crafted serialization problem that will let you run runtime exec. So I've got some string data, and I managed to get that string data down to calling runtime exec. Right. So there are fixes coming in serialization. They're like the whitelisting. The interesting thing with whitelisting is that that requires you to understand all the classes that you're going to be loading. So you're going to be working harder. But if you don't do that, then you're open to abuse. I talked about crashing your system. This number, not particularly obvious, triggers a vulnerability, which is to say a bug in some code. And the net is that the code loops. Right, it's just calculations. So people were attacking sites by finding where they were receiving simple doubles and weren't checking. Not that you would know that you should be checking specifically for that number, but that number was just injected. And it gets injected and it gets to your VM and you parse it and your system just hangs. Right? Nobody thought about it because nobody thought about the consequences. It was just an obscure, oh, that's funny, but nobody thought about what you could do with it. Okay? This is why it had such a low score, because it was academic and not practical. So you can't rely on these things. You have to make your own assessments. Another one, Apache struts, remote code execution. Yeah, well, this was just very complicated, but once it was published, it became really easy to get a string into runtime exec with no validation. Right, and you probably heard about this one, quite recent. Lots of people who use Apache struts had to get it fixed, and it was all over the place, and so we put a lot of effort. This has two things to show you. One is that, again, the exploit is very complicated, right? but it finds a simple weakness and then finds how to get to that simple weakness, right? And then once we'd figured it, we could find it, which is cool, but then the fixing of it, because everybody was using that code, was horrific. If you have this is the thing, once a vulnerability is reported, it's a ticking time bomb. And if it's really easy to exploit, it's going to be like that. People will be knocking at your door. Nowadays, if you put a system on the internet, well, if you fired up a VM, a machine on a cloud of your choice, nowadays the chances are that somebody will be knocking at your door within about 15 seconds. And once they know what system you are, you can expect a targeted attack within 40 minutes. It's that bad. And then there are really silly ones, where this is a really classic of somebody who won't be nameless, who is nameless. You can go Google this one and find out who it is. What happened is that JWP was enabled, and it wasn't spotted. So when the application was deployed, even the ops guys who were deploying it didn't spot that allowing this port open was a bad thing. And somebody just scanned for it and made some money. But the net was that if you wanted to exploit that, you have full debug access to somebody's application. Think what you could do with full access to somebody's application in debug mode. Right? That's just silly. Right, so let me give you some more code. I'm just going to give you, some of these are versions of real vulnerabilities. And now I want to talk about, there's no big thing here. It's trying to get your head around how the little bits of code that you write can be exploited. So here's a really helpful class loader. And there's a properties file at the top, and it's backed up by system properties. And the default puts a couple of values in. Imagine it's going to be doing some data parsing. So you're going to say, I need to get the default parser, and maybe I've got some data type called foo, and I want to get the class from that. So it's that sort of, I have a thing, and I need to find the class to handle it. So you can see that I've got the default one, it's called foo.stringhandler, and I've got another one called foo, and I've got a packet class name there. So then I've got some code that talks about how to load it. And it just tries to create a class, which is cool. Okay. And if it doesn't find it, it just throws an exception and says, couldn't do it. Nothing, doesn't seem to be anything wrong with that sort of code at all. Okay. So let's put some examples in there. So if I use that helpful class and I say, give me the default value, what you get when you run it is you get class for default equals class foo.stringhandler. That's what you'd expect. Right? It's giving me back the data I was expecting. Right? And if I now tried to ask it for the foo handler, now in this example we're assuming that string name that represents a class doesn't exist. So I run that and I get class not found exception. Could not create class for handler foo with value blah. I bet you've seen all sorts of error messages that have that sort of style. Really helpful. You tried to do something, it didn't work. Okay. What happened if I was to use java.ext.ders? Well, I run that, and I get, can't find the class, but luckily, it gives me the full extensions path. So you saw what happened? Because my properties file was backed by system properties, because that's a nice thing, we do that a lot. It's good to allow you to do -d on the Java execution so you can add things to it. The downside is, because I'm not doing any checking, I asked for something that I probably shouldn't have asked for. Right. So this is a style of a real vulnerability, right? Where we were being helpful, and the net of being helpful was that we were helping an attacker walk through the data in our system. Okay. Right. And so if you take that sort of thing where you're being helpful, and you add in the missing URL decoder, and you add in the remote code execution, it's so easy to build a system where your application is compromised. So it means that you can add vulnerabilities as being bugs and features, and developer aids. So let's summarize. I hope you understand. I can't share with you all the details of the code. You can go try and figure it out yourself. You can go off to the repositories and you can go look at the innocuous fixes and try and figure out what the vulnerability is. But in general, even if you look at the code, your mindset's not in there about how it's exploited, right? But there are things that you can start to do, right? This is what you've got to start thinking about. First off is currency. There are people out there who are trying to steal everything. And if you are not current, you are providing a gateway in. And the older the software is that you're using, the more vulnerabilities will be discovered, and the more likely you are to be attacked. Right? So if you don't start to break up your application, so good news, we've got things like Docker and microservices, and they're beginning to help in that way. Right? Think about how you're going to prevent this thing. Think about the access controls that you have to systems. How much are you letting people do? Not because you don't trust them, but because if their system is compromised, can they get into and doing things to your system that you weren't expecting? Right? You have to compartmentalize, right? And you have to turn down your level of helpfulness and flexibility. Designing architectures where you go, we'll specify this later, right now it's generic, because that'll be good, can be a bad thing. And you have to think about the consequences of letting stuff in. If you let data into your system and you're not checking it, then you're just going to get burnt. You have to be focusing on every piece of data that comes in, whatever type it is you're validating. Right? You need to go learn about penetration testing. It's insightful to go see what the guys who are trying to break into your system legitimately do to get in. Right? There's a link there off to the Oracle website. There's a secure coding guide. It's been around for a long time. Go have a look. It will tell you how to deal with some of these things. I don't find very many people have ever been there and read that document. Right? Take away that things that you do to make your development life easier provides a gateway in. Right? So unfortunately, we've got to become tougher, and we've got to find out, we're going to take a bit more pain to reduce the options for the guys who are attacking us. You've got to keep sitting there and reducing your risk. Keep things up to date. Vulnerability scanning tools, there's a whole bunch of them out there. You can scan source code, you can do basics at a lint level, all the way up to things that will do binary signature analysis. There are tools that will scan Docker images for you to tell you what vulnerabilities you've got. You can get that on Docker. I mean, IBM Bluemix has that. There's all sorts of places where you can get more information about your level of risk. Right? It isn't about you ignoring this. It is not about you saying, oh, it's just another CPU. Let's do it next week. It's like you have to get this into a process where you're updating this all the time. And you have to be looking at not just JVMs. Look at all the code that you're using. Are there new versions? If you've got static references in your Maven files, Maven POMs, about this version, and you don't go and revisit those on a regular basis, I know that you're going to have to think about retesting. But if you don't, you're using code that's getting old. And if you're not checking to see whether that stuff has vulnerabilities, you're at risk. Right? Other things, yes. Don't write these things yourself. If you can find somebody who's doing it that's got a good version, use that. Don't write your own XML parsers. Don't write your own crypto code. Don't think that hashing is encryption. Use what's out there. Use what people are investing in, because so many weaknesses come from homegrown code. Right? And as I said, basically, data, if it comes in and you're not validating it, then you're vulnerable. Right? These guys are out there, right? They are making lots of money on us, and it's going to get worse before it gets better. But if we as a community aren't realizing what we've got to do, right? We aren't realizing the effort that we have to put into thinking about how we design systems, how we code them, and how we keep up to date, and why we keep up to date, right? It's just going to get worse. And on that note, I will stop. Thank you. So, this is good. That says 0, and I thought I had a couple of minutes left. Any questions? Oh, I've got one here. Hello.
Hello. I would like to add an addition in your talk. I know that many people disable Java bytecode verification in production as well, and it's also opens some vulnerability in applications. But maybe you know some examples when someone tried to exploit it.
Sorry, what was the thing?
Java bytecode verification. Some people disable it, and you don't talk it in your presentation, but it's common source of vulnerabilities.
Yes, you're quite right. So yeah, bytecode verification. Yeah, I didn't touch that, mostly because I wanted to talk about our coding style. But yeah, if we have tools that mean you can check, so it's data verification. If you have a tool to check to verify your data, turn it on. That's it. I mean, there are no, I mean, you may say it's going to cost me performance, or I might test things, but I can't stress it enough. If we don't take that pain, then you're open to attack. And I think the Wannacry ransomware stuff shows you just how vulnerable we are. And it may, we'll have the politics about whether or not Microsoft had a problem or when it's the NSA and stuff like that, but that's just one example. Right. There are lots of places where people are out trying to do that. So it's just, we have to take this pain. We have to figure out how to fix it. So yeah, so byte verification, turn it on, take the pain. Yeah. Anybody else? Or they're all rushing off. Thank you very much.